Good morning, students. Today we will discuss about the second experiment corresponding to the network filters and transmission lines, and the title of that experiment is to measure the image impedance of asymmetrical T or pi network. Okay, so first of all we will be understanding about the asymmetrical T network, and these are the following apparatus required. That is resistors with the different values, okay, that may be in terms of 2.2 kilo ohm, you can take as 4.7 kilo ohm, or it can be in terms of 820 ohms. Okay, next is the voltmeter, ammeter, and few of the connecting wires. Okay, so this is what the apparatus required. So before explaining the practical demonstration, I'm just giving you the theoretical view. So in case of the asymmetrical T network, we have to just calculate the image impedance. Image impedance is being considered as when the network is terminated with the image impedance, in which if we are calculating the impedance at the input of this particular network, okay, keeping my second that is the output port as open or the short circuited, in that case whatever the impedance I am calculating, okay, similarly if I am just calculating the impedance calculating from the output terminals by keeping my input terminals or that is open circuited or short circuited, in that case those values will not be equal. The impedance calculated from the input or the impedance which is I am calculating from the output, okay, they are not going to be same, they are different. So that kind of impedance is being considered as image, because we are talking about the asymmetrical networks. In asymmetrical networks, the values of these impedances will be different. Okay, that is two series arms, they will be having the different value of the impedances. So that is why we are having the different values of the that is impedance calculated at the input or at the output side. Okay, so let us now understand this one. That is, first of all, we will be calculating the impedance, image impedance, that is only at the input port by considering both the aspects, by keeping the second port open circuited. Then second time we will be, okay, terminating it by a kind of the jumper or by a that is connecting wire that will be simply shorted. Okay, so this is how we will be connecting a milliammeter over here. Okay, and after that this will be the voltmeter. Then we have to calculate the values of the voltage or current. Okay, and similarly over here we will be then calculating the short circuit, and later we have to then calculate the values of the that is characteristic impedance measured at the input port by taking the square root and taking the multiplication of both the impedances, one at the time of the open circuited and then another at the time of the short circuited impedance. Okay, and the same process we have to also repeat for calculating the impedance, that is the image impedance looking from the output side. Okay, in which what we have to do, that is this time we will be keep the terminals of my input port as open circuited or the short circuited, and this time I have to also change my connections. This my milliammeter will be now connected towards the that is output port terminals, that is across 2 and 2 dash, and please check the connections. This time my positive terminal will be connected over here, because I will be supplying some of the voltage from the DC power supply, and this is my voltmeter. Okay, so this time I will be first of all calculating the open circuited impedance, and then later on we will be calculating the short circuit, and the same concept we have to use. So this is how we have to then calculate the that is characteristic impedance for the that is output terminals as seen from the output terminals. So this is what the observation table you have to draw, that is this will be the open circuited impedance calculated at the input terminals, short circuit impedance calculated at the input terminals, and this is my final that is image impedance which is calculated at the input terminals. And so these readings we will be just verifying over here. That is how we are going to get these values. You can take a single reading or you can take more than one reading. Okay, and after that whatever the values of the voltage or current you are calculating by having the open circuit connection, then you have to take their that is division, you have to divide them in order to find out the open circuited impedance as well as the short circuited impedance. Clear? And later on you have to then calculate this image impedance at the input port. Let us now start the practical demonstration. So this is our DC power supply. Okay, as I have explained you in my previous video, over here we will be using the power supply A, which is having the maximum reading over here, maximum voltage, it is 30 volt. Okay, and from there we will be also having a DC voltmeter, as in the previous case we have used up to the 30 volt only. So I'm just connecting it to the 30 volt, and this is my DC ammeter, which is maximum, its calibration is up to 30 milliampere. Value of milli is 10 raised to power minus 3. Okay, so over here currently we are talking about a T network, asymmetrical T network. So if you see that we have used all these resistance values are different. This is somewhat that is 820. Okay, and this is being considered as 4.7, and this is 2.2. So we are having all the different value resistances are being connected over here, and if you want to check, we can also check it from the multimeter as well. And after that these are the wires coming from the DC ammeter. Okay, so this is how it is being connected over here. So this is my negative terminal, and this is the red terminal, and this is how it is also being connected to the voltmeter, and further the connections are coming from the DC power supply. So over here, first of all, if you see that this is my extra jumper wire, still it is not connected over here. It means I'm talking about the open circuited connections. So let's suppose I'm just giving a 4 volt, okay, from the DC power supply. Let us now check what will be the open circuited impedance calculated at when I'm just looking from the input. So from the voltmeter it is giving me 5 volt, and over here on the millimeter it is giving me nearly, you can say, 0.5 milliampere reading. So the same reading we have just noted down over here. Similarly, if I want to take more than one reading, I'll just okay, change the value of the voltage, okay, by moving this knob. Let's suppose I'm just taking this one, okay, or slightly we can increase it. And what change you will see here, that if I am just calibrating the voltage from my DC power supply nearly to 6.6 volts, so over here on the that is voltmeter, I am able to have that value nearly to 8 volts. Okay, and what is the value visible from the milliammeter? It is being, you can see, it's being coming in terms of it is approximate, you can say it's 1 milliampere. Okay, so this value is being calculated nearly same as 0.5 milliampere only. Okay, so we can just have the correction over here. So this is 0.5, or we can just correct it. Okay, so this is the value which is being calculated. Okay, just a minute. This is being calculated under the open circuited, so it is 8 volt and it is 0.5 milliampere. So we can just write it as 0.5 milliampere. Okay. Now we have to repeat the process for the short circuiting. For the short circuiting beta, what we will be doing over here, that is this is the jumper wire, and I will be now short circuiting my output terminals by connecting this particular wire over here, and yes, now it is being considered as that my output port has been short circuited. Clear? And now I just want to calculate the values, okay, by just first of all keeping it at the previous value. Let's suppose it's being 4.1, and over here we can see that when my output port is being short circuited, it is just being reading a value nearly 5 volts. Okay, so this is what we have written, 5 volts, and what is the current it is reading? It is reading nearly 1 ampere. Okay, so yes, it is equals to 1 milliampere over here. Okay, similarly with the short circuit, if I want to take the another reading, then we can calibrate, okay, that particular voltage given from the DC power supply to the previous value that we have considered for the open circuited connections. Okay, and over here what we will be observing, that it is just being under the short circuiting, the values have been getting, okay, it is up to 8 volt, and the current is being getting doubled, and over it here it is being getting 2 milliampere. So over here we have just written the values as 8 volt and 2 milliampere, and later on you can then calculate their that is the ratio, okay, in terms of the open circuited impedance as well as the short circuiting, and then complete this table. Okay, so next part what we have to now do, that we have to now repeat the process. Okay, in case of calculating the image impedance calculated from the from the output terminals. Okay, this time we have to consider the open circuited impedance, my input terminals to be open circuited as well as to input terminals to be short circuited. If you just see over here, that is this time the connections has been changed, and we are connecting the ammeter over here. Okay, that is across the output terminals, and we are also giving the voltage from the DC power supply. This is my black terminal and this is the red terminal, and this is how the voltmeter is also connected to that particular second terminal. And if you see that on my input port, none of the wire is connected. That means this time I am treating that as open circuited, sir. Okay, so my input terminals are properly they are considered as open circuited. Let us now calculate the values in terms of the voltmeter and the that is voltage and current. So this is how we are giving that particular voltage from the DC power supply, and for the given applied voltage on the voltage that we are able to measure on the voltmeter is nearly that we can just consider is 7.5. Okay, so we can just mention over here that is for the open circuited, I'm just getting the first value as the 7.5 volt. Okay, and what is the current that we are able to measure over here? So it is nearly 0.5 milliampere. So just please write over here, it is 0.5 milliampere. Okay, similarly if we want another reading, so in that case we can calibrate it. So over here we are getting nearly, that is the voltage that we are getting is it's being 12 volt. Okay, and the current that we are able to measure over here is 1 milliampere. Okay, similarly we can now calculate for the short circuit, and let us take a jumper wire. So this is what being considered as the jumper wire, and over here I'll be connecting it here. So this is being considered as the short circuited connection over here, which is being done at the input port, and let us now calculate the values. Okay, it has been already been discussed in the part-1. You will be getting the picture. You will get probably like today, tomorrow, or Monday. You will be getting the picture. We will be teaching the entire details, all from the very basic. From the very starting, we will be teaching. We will be taking the theory classes, practical classes. Okay. Otherwise, in the section, we will not be checking 201. So over here we are just coming across the values will be, you can say that it will be it is 6, it's 7, 8, it's been getting 8.5, and over here we are getting the values like 1 or 2. Okay, so here we can have the values in terms of 8.5 volts and 2 milliampere. Similarly for the short circuited, if we want to take the another reading, we can just calibrate it to the previous value, that was nearly 10.2 to like this much, and over here we are able to find out the values are 12.5, nearly 12.5, and over here it is 3 milliampere. So it is 12.5 volt and it is 3 milliampere. And if you see over here, that is the values that we are calculating by looking at the input port or looking at the output port, these values are not matching themselves. Okay, they are not the same values. Clear? So that means that if I am just calculating that is the impedance from the input terminals, looking at the input terminals, or if I am calculating looking from the output terminals, because it is the asymmetrical network, those impedances, image impedances, will not be same. So that is what is being considered as the concept of the asymmetrical T network. Okay, thank you students. In the next video we will be discussing about the that is the calculation based on the that is asymmetrical pi network. Thank you.